Dear students, in previous lecture we discussed solutions of several important problems of normal distribution. In today's lecture we will talk about few more important problems of normal distribution. Question number 1 was done in previous lecture with several parts. Now question number 2, where mean height of several soldiers is given as 68.22 inches and their variance is 10.8 inches. And now we have to find how many soldiers in a regiment of 1000 would you expect is to be over 6 feet tall. So there are several statements given in the problem which we have to consider as mean means mu equals to 68.22 inches and variance means sigma square is 10.8 inch. So sigma is square root of 10.8 because that's value of sigma square. So sigma is root 10.8 is 3.286 inches. And as we know that we have to change or convert the problem from x model to z model using this equation z equals to x minus mu upon sigma. And what we have to get how many soldiers in a regiment of 1000 we expect, means expectation is required where variables value is 1000. So we need to get a probability and then to multiply it with 1000 to get the result. And probability of what? Probability of over 6 feet tall means px greater than 72. Why? Because the problem is in inches, so we have to change that 6 feet into inch, that is equals to 72 inch, and over 6 feet means greater than 72. So in x model we need probability x greater than 72, and for that x equals to 72, value of z is 1.15. That's why px greater than 72, if we convert it into z model, reduces to z greater than 1.15, and that might be x equals to 72, so z equals to 1.15 and z greater than 1.15 means that particular area. And we have discussed lots of these cases in or similar cases in previous lecture. At z greater than 1.15 means that area is equals to 0.5 is whole right hand area. So from that 0.5 we subtract this particular area, that is z equals to 0 to, at here z is 1.15. So 0.5 minus p 0 less than z less than 1.15. By doing that, that probability is coming in this model 0 less than z less than some positive value what we need for finding this value from table. And we have discussed how we can see the table. So that table is there with that previous lecture. If you check it, you will find that value for 1.15 from table is 0.3749. That means the probability of x greater than 72 means that is of any soldier which is over 6 feet tall is 0.1251. And what we need? Expected number of soldiers out of 1000 of this kind. So the final result is 1000 into 0.1251, that is 125.1, but number of soldiers can't be 125.1, so approximated as 125. Question number 3, in a normal distribution 31% items are under 45 and 8% are over 64. What is the mean and standard deviation of the distribution? Means it's a reverse kind of problem where we need to calculate mean and standard deviation, means mu and sigma. Normally mu and sigma are given and probabilities are required, but here probability is given with that first line of this problem. We will see how. And then mu and sigma are required. So as per that given statement, 31% items means 0.31, 0.31 under 45. So px under 45 means less than 45 is 0.31. and 8% means 0.08, as you can see, or over 64 means px over 64 means greater than 64 is equals to 0.08. So two probabilities are given and mu and sigma are to be calculated from oversight. Now using those two results we make a diagram as usual. Diagrams are always required for any solving any problem of normal distribution. That bell shaped curve is symmetric with respect to this line x equals to mu, z equals to 0, we always know about that, and x less than 45, so that is x equals to 45, and less than 45 means before that, that is 0.31, so that area is 0.31, and whole left hand side before this line is 0.5, so if it's 0.31, remaining that particular area is 0.19. Then x greater than 64, say that is we are assuming it over right hand side, one left hand side result, one right hand side, x equals to 64, and greater than 64 means after that it is 0.08, and whole right hand side area is 0.5, so you have to get that area from by subtracting 0.08 from 0.5, that is 0.42. Now we are assuming that over negative side of z, at x equals to 45 z is minus z1, and at x equals to 64 z is plus z2. Then using that diagram along with those results we have to calculate mu and sigma. So px less than 45 equals to 0.31 indicates that left hand side etc. the mean. Now we know about that result, z equals to x minus mu upon sigma, and here z is at minus z1, and in that case x is 45 minus mu upon sigma. Mu and sigma are unknown which we have to calculate. So one equation at that point z equals to minus z1, and then at other point z equals to z2, so z means z2 equals to x minus mu, x equals to 64, so 64 minus mu upon sigma. So that is about equation 1 and 2. Now what is required? Now we have to calculate those left hand sides, that is if we can calculate that value of minus z1 and value of z2 and can substitute in these two equations 1 and 2, then two unknowns mu and sigma will be remained in these two equations, and then we can easily solve two equations to get values of two unknowns mu and sigma. So our target is to find minus z1 and plus z2 from where? From these results. How? Because we can use the tables in reverse direction. Up to this we know that we can find results from table from first column to in between the table, but here we have to search for that probability 0.31 and 0.08 from the table to get their left hand side in the first column. We will see how we can calculate these minus z1 and z2 using table. Now using that first given result, px less than 45 equals to 0.31, before using table we have to convert it in z model and in specific 0 less than z less than a form. For that, as we know that at if x less than 45, then z obviously less than minus z1, because at x equals to 45 we assumed z equals to minus z1, that is equals to 0.31, and z less than minus z1, some negative value of z model, as we have discussed a lot of such cases in previous lecture, finally reduces to 0.5 minus p minus z1 to 0 equals to 0.31 using the diagram, and then that 0.31 taken over left hand side minus p z1 less than z less than 0 right hand side, and minus z1 to 0 is symmetric to 0 to z1. So finally that particular format is to be utilized through table. P0 less than z less than some positive value z1 equals to 0.19, and because of that z1 is 0.50 using the table. In final slide of this lecture, you just remember this. I will show you how it's coming. That is, you have to remember, if probability is 0.19, then why Z1 is 0.50. That I will show you in the end of this lecture. Then we start with second case, px greater than 64 equals to 0.08. At x equals to 64, we have z equals to z2. So the problem converted into z, and then z greater than z2 means, using diagram, zero point 0.5 minus 0 to z2, 0 less than z less than z2. Then by simplifying it, that equation is finally in this 0 less than z less than a form. So p 0 less than z less than z2 is 0.42. Now you remember this particular expression also. If this probability is 0.42, then value of z2 is 1.41, which I will show you next slide, final slide of this lecture. Now using these values of z1 and z2, we have to substitute these values in equation 1 and 2 of previous slide, and by substituting z1 and z2 at particular places in equation 1 and 2, now we have two equations 3 and 4 in two unknowns, mu and sigma. By solving two equations in two unknowns, it is the easier task. The values of mu and sigma are finally obtained as mu approximately equals to 50, and sigma, if mu is 50, then sigma equals to 10. So these are the required values. The mean equals to 50 and standard deviation equals to 10. So it's about completing this solution. But in next slide, as I told you, remember the explanation of these two things in table, that if the probability is 0.19, then why z1 is 0.50, and if the probability is 0.42, why the z2's value is 1.41. Now we discuss the remaining queries of the question number 3. What I was saying in previous slide, that if probability is 0.19, which we have to search inside the table, then y value of z, that was z1 in that problem, is 0.50. So probability is 0.19. So what we have to do, we have to search value of probability inside the table which is closest to 0.19. As you can check it, it's 0.17, 0.18, 1844, now 0.1879. Now looking close to 0.19, then the next one is 0.1915. So as we can see, two values are closest up to this from 0.19, 0.1879 just before 0.19 and 0.1915 just after 0.19. Which one is much closer out of these two values? Say in comparison of 0.1879 and 0.1915, obviously 0.1915 is closest to 0.19. That's what we have to do. The value of probability inside the table closest to which particular value, we have to find that value. Now it's 0.1915. It's coming at intersection of 0.5 and 0.00. So value of z, which was z1 in the previous problem, is 0.5, then 00 means 0.50. Fine. Let's talk over one more query of question number 3. At probability equals to 0.42, why the value of z2 was 1.41. Now probability 0.42, find the probability in the table which is closest to 0.42. You will find it's 4015, then increasing 4162, 4177, now looking close to 0.42, then 4192, much closer to 0.42, then 0.4207. That is, as it looks, these two values are closest out of all in this table to 0.42, and if we compare these two, slight difference in their as far as the closeness to 0.42 is concerned, but finally in comparison of 0.4192, 0.4207 is much closer to 0.42. Now that 0.4207 is coming as an intersection of 1.4 and 0.01, means 1.4 and 0.01 will make together 1.41. That is why for probability 0.42 the value of Z2 was 1.41 in previous problem. So it's all about that all important problem of normal distribution. So with this particular discussion we conclude almost everything regarding normal distribution.